Dear students, welcome to our class on drag coefficient. DRAG, drag coefficient. Now, so very interesting as agrometeorologists, particularly we micrometeorologists shall understand what is a drag, what is a drag coefficient, so that we can apply it in innumerable ways. Now, what is it? What is the definition of drag coefficient? Now, it is a dimensionless quantity. It is a dimensionless quantity that is used to quantify a dimensionless quantity that is used to quantify the drag or resistance. The drag or resistance of an object, okay, of an object in a fluid environment. This is in the air. Air is a fluid environment. Now, such as air or water. Once again, for your academic interest, drag coefficient, a dimensionless quantity that is used to quantify the drag or resistance of an object in a fluid environment such as air or water. Now, see what is the formula. Very interesting, simplest formula I am going to explain to you now. Formula for drag coefficient is CD. CD is the drag coefficient, D by rho. Velocity square A by 2. What is it? Now, see, CD is the drag coefficient, D is the drag in newtons, A, reference area. Say for example, you are taking this as a crop. Reference area is crop surface is the reference area. Okay. Now, density kgs per meter cube, we know. Velocity meters per second. Now, so CD is equal to D by rho V square A by 2. That means if a crop is there, crop surface is there, how much momentum is coming, how much air is coming, how much resistance is offered by the crop, we come to know through drag coefficient. Of course, momentum is explained by Newton's law of viscosity. Same thing only, I am not saying anything else. Now, see, let us see what is the how we can measure the drag resistance. Say for example, drag resistance can be measured by two ways. Say for example, if seeds are there, agriculture seeds are there, drop method we call it as. What is meant by drop method? Say for example, so these are the grains, okay, paddy grains, or you can say red gram grains. Drop method means this is what we drop it. So what exactly drop method says is that this method involves dropping of the material from certain height, by which the material particles attain their terminal velocity. Material particles attain the terminal velocity for dropping certain distance from here to this distance. What is the terminal velocity? So through this method we can know it. And what is the second method? Suspension method. Say for example, a vertical, you can say tube is there like this. This is a vertical tube. Now by blowing air in a tube and measuring the air speed at the moment when the material particle is suspended. This is I am showing it to you. This is the vertical tube. Horizontal I am showing it to you. There is a material here. Now, so here we see the wind speed, here we see the wind speed. So the difference between these two, we take it. Now, under this position, the weight of the particle is equal to the drag force. The weight of the particle here is equal to the drag force. Weight of the particle here I kept it. So otherwise, you can keep this particular also. Now, these are the two methods. Now, what are its applications? Simple, very simple, and very interesting also. If a crop is there at maximum LAI, at maximum leaf area index, the drag coefficient will be very high. At low leaf area indices, the drag coefficient will be very less. Maximum LAI, maximum drag coefficient, vice versa. Now, similarly, when we are interested to remove the grains from paddy, harvested paddy, how we can remove? Yes. How we can remove is very interesting. We can force the wind. Material what we wanted is the grains without losing a single grain from the paddy husk we wanted. So through the drag force we collect it. Not only collecting the seed by drag force, but also we can differentiate the sizes also. Sizes play an important role as far as the seed material, not seed material is concerned. So therefore we wanted to use the seed material by using the drag coefficient. See, we can see that, surfaces, same principle. Area of reference means, area of the grain, density, velocity, okay, all these things. Now, so with this drag coefficient, I would like to conclude, and we continue micrometrology. Thank you very much for your patient hearing.